Hello, good morning, students. How are you doing? I am Miss Adana Ogu, your chemistry teacher. I hope you've been keeping safe. So today, I will be taking a topic in chemistry for SS1 class. So I want to specially welcome you to this class, and I hope you will learn all that we need to learn today. So to get the full benefit of this class, try as much as possible not to be distracted, and make sure you had already copied the notes that I have sent to you on the school website. You copied it and try and follow the note as this video is going on so that you can get the full benefit of the class. So remember I said it's SS1 class, and the topic today we'll be looking at a topic in SS1. So, and the topic is for week 3. That topic is base. Remember last week, last time or in the last class, we talked about um, acid, and that topic was for week 1 and week 2. So we said that acid are substances which dissolve in water to give us hydrozonium ion. And we said that the characteristic property of acid is the production of hydrogen ion, which combines with water molecule to give us that hydrozonium ion. We talked about that in our last class, and we talked about concentrated and weak acid, for example, H2SO4, tetraoxosulfacic acid, hydrochloric acid, HCl, and triazonitrate acid, that's HNO3, are strong acid, while weak acid are like ethanoic acid, organic acid, which ionize partially in solution, are weak acid. Strong acid ionize completely in solution. So other examples of weak acid are H2CO3, that's triazo carbonate 5 acid, and tetraoxophosphate 6 phosphate 5 acid. Those are examples of weak acid. We talked about concentrated and dilute acid which contain large amount of the acid in solution is concentrated, while acid which contain small amount of the acid in solution is dilute. Then we talked about basicity of acid, number of replaceable hydrogen atom in a molecule of an acid. Then we talked about the physical properties. Acid are sour, they have sour taste, they turn blue litmus red, and the concentrated form of them are corrosive. That means they can burn. I would say that acid react with base to give us salt and water. So today we are looking at what base is. I'm sure when you saw acid react with base to give us salt and water, you'll be like, what is a base? So we are looking at what a base is today. So a base, so like I said, is with 3 topics, and the topic is base. So at the end of this class, there are specific things you need to learn. Number 1 is that you should be able to define as a base and an alkaline. You should be able to differentiate between a base and an alkaline. You should be able to give examples of strong and weak alkaline, state the physical and chemical properties of bases/alkalis, and then mention the uses of bases and alkaline. So an alkali, so state the uses of base and alkali. Now let's look at what bases are. So what is base? A base is a substance which will neutralize an acid to form salt and water. That was one of the chemical reactions we said, that acid reacts with base to give us salt and water only, and that reaction is known as neutralization reaction. So by definition, a base is a substance which will neutralize an acid to form salt and water only. Now look at it. Most oxides and hydroxide of metals are bases. For example, you have, let's look at the example. You have N2O, that's sodium hydroxide, potassium hydroxide, calcium, sodium oxide, potassium oxide, calcium oxide, magnesium oxide. Please, that's sodium oxide, potassium oxide, calcium oxide, and magnesium oxide. These are basic oxides, and you agree with me that sodium, potassium, calcium, and magnesium are melters. So oxide of these metals are bases, while hydroxide of metals as well are bases. Look at the example: sodium hydroxide, potassium hydroxide, magnesium hydroxide, aluminum hydroxide. So sodium, potassium, magnesium, and aluminum are all metals. So any oxides or hydroxide of metals are bases, and so they will react with an acid to give us salt and water as the only product. Now, going on, let's look at this. So bases and alkaline. So most bases are insoluble. Bases are insoluble. That means they don't dissolve in water. But however, some few of them will dissolve in water to give us alkaline. So any base that dissolve in water to give us any base that dissolve in water is an alkaline. Now look at this Venn diagram. You have different oxide and one magnesium oxide, but everything in this diagram is they are all bases. But specifically, you see, out of the bases that were given, you have two out of them cycled in another put in put in another cycle. So you have sodium hydroxide and potassium hydroxide. Those are alkaline. So although they are bases, but they are specifically alkaline. So let's define what an alkaline is. An alkaline is a type of base that is soluble in water. Hope you get it. So all base react with an acid or neutralize an acid to give us salt and water. But a base that is soluble in water is known as alkaline, and they are mostly hydroxides. So there are hydroxides that are soluble in water. So any soluble hydroxide is an alkaline. So they ionize to form hydroxide ion. So in an alkaline we ionize to form hydroxide ion. That is OH minus. Now look at the specific example. We have sodium hydroxide, give us Na plus and OH minus. Are you seeing that? So another example, you have calcium hydroxide, we give you Ca2 plus COH minus. Why? Because you have two hydroxide ions, so it will produce two hydrogen ion when dissolved in water. Remember that I said any soluble hydroxide is a base. So a hydroxide which is soluble in water is a base. Now look at these examples of strong base. The same way you have strong acid, that's the same way you have weak strong and weak acid. That's the same way you have strong and weak alkaline. So the examples of strong alkaline is sodium hydroxide, potassium hydroxide, while examples of weak alkaline is ammonium hydroxide, or we call it aqueous ammonia. Now it's either represented as NH4OH or NH3. Now you agree with me that this is ammonia, this is water, so that's why the name is aqueous ammonia or ammonium hydroxide. Now if you count here, you have one nitrogen, four hydrogen atoms here. I have three here, and you have five rather, four here and one of these. So you have five hydrogen atoms and one oxygen. So ammonium hydroxide or aqueous hydroxide is an example of a weak alkaline, while sodium hydroxide and potassium hydroxide are examples of strong alkaline. So hope you know specific examples now. Now going on, still looking at alkaline. I said alkaline, an alkaline is a base, but not all bases are alkaline. That means, for example, you have, consider this example now. Look at this. Na2O plus HCl. Remember we said that an acid, a base will neutralize an acid to give us salt and water. Sodium oxide reacts with hydrochloric acid, which is an acid, to give you a salt, sodium chloride, and water. Then look at this, which is a base, sodium hydroxide, will react with an acid as well to give you salt and water. Take another example. You have calcium oxide reacting with an acid to give you salt and water. This is a base, but it's not an alkaline because it's not soluble it's not it is not an hydroxide. So an hydroxide which is soluble in water is a base. But I mean, an hydroxide which is soluble in water is an alkaline and also a base as well. So calcium hydroxide is a base, but it's not an alkaline. So this is an alkaline. Sodium hydroxide reacts with tetraoxosulfates, give you salt as well, and then water. Remember, these are the products of neutralization reaction. So and all bases, so, I mean, all alkaline are bases, but not all bases are alkalis. Meaning that an alkaline is a type of base. Hope we understand this now. So moving on, let's look at the physical property of bases and alkaline. A base and alkaline have bitter tastes. So they turn red litmus blue, and they are slippery to touch. When you touch them, they are slippery. The concentrated form of them of sodium hydroxide and potassium hydroxide are corrosive. Now the concentrated form of sodium hydroxide and calcium hydroxide are concentrated form of sodium hydroxide and potassium hydroxide are corrosive. That means they can cause burning effect, like what we saw when we're talking about acid. Now, remember, now because of that word concentrated, I want to throw more light about concentrated and dilute solution. Now, a dilute solution contains small amount of solid in a large amount of solution. Now, look at it. This is a dilute solution. If you look, small amount of the solute in a large amount of the solution, while a concentrated large amount of solute in the same amount of solution. So this is concentrated, while this is dilute. So moving on, the next thing we are going to look at today is chemical properties of bases or alkaline. Number one is that neutralization reaction with an acid to give you salt and water. Now, if you look at this example that I cited here, magnesium hydroxide. Magnesium hydroxide is a base, but it's not an alkaline. The reason is because magnesium hydroxide is insoluble in water. So because it's insoluble in water, it is a base, not an alkaline. But potassium hydroxide, which is an alkaline because it is soluble in water, reacts with this acid to give you this salt and water. And this one, which is a base, reacts with acid to give us salt and water. Hope we get that. Let me say it again. Magnesium hydroxide is insoluble in water, so it will react with an acid to give you salt and water. This potassium hydroxide is a base and an alkaline because it is soluble in water. So because it's soluble in water, it is an alkaline, so it will give you salt and water as well. So moving on, another chemical reaction of bases is that they produce ammonium gas when reacted with ammonium salt. They produce ammonia gas, They produce ammonia gas when reacted with, when heated with ammonium salt. So this reaction is usually used to test what ALKALIS. Now, when you go to the lab and maybe you see a solution and you are not sure of it, when you react such a solution with an ammonium salt, when you ammonium gas is given off, ammonium gas usually have pungent smell, very strong pungent smell. So when you perceive that smell, that tells you that that substance is an alkaline. Now look at the example that I have: sodium hydroxide reacting with this ammonium salt, this ammonium thiazonitrate 5 to give you this ammonium gas, to give us ammonium gas. The calcium hydroxide reacting with another ammonium salt to give you ammonium gas. These are chemical reactions that alkaline and bases undergo. Remember, one of them is neutralization reaction between acid and base to give you salt and water. And another one is reaction between an alkaline with ammonium salt to give off ammonia gas. So alkalines react with ammonium salt to give you ammonia gas. Then still on the topic, we are looking at the uses of bases or alkaline. Now, number one is that bases such as sodium hydroxide, they are used for making soap. And used to make hard soap. They are used in the paper industry for making paper. Potassium hydroxide is also used to make soap, but in this case, those soap are called soft soap, like soaps like toilet soap, like you have different brand like Joy soap. Those are actually soft soap, so they are made with potassium hydroxide. Now, magnesium hydroxide is used to make antacid, that is to help indigestion. For example, when you have acidic substance in your stomach, for example, you have indigestion or there is discomfort in your stomach, you are asked to take Miss-Mag. Miss-Mag is actually made of magnesium hydroxide. So that, and also magnesium hydroxide is also used in toothpaste. Sometimes you find them in toothpaste. So calcium hydroxide is used to neutralize acidic soil in agricultural science. So they use it to neutralize acidic soil, a soil that is very acidic. So in the presence of a caustic soda or calcium hydroxide, they will to neutralize such a soil. And there are other several uses of bases which I gave you in your notes. Please make endeavor to go to your notes and look at them. There are quite a number of them that are given to you in your notes. So this is where we are going to end the class for today. Thank you very much for listening, and God bless you. See you in the next class, and God bless you. And before I end the lesson, I'll quickly recall what I said. I said that bases are substances which neutralize an acid to give salt and water. And I said that a type of base is an alkaline is a type of base which is soluble in water. And hydroxide, which is soluble in water, is known as an alkaline. So all alkaline are bases, but not all bases are alkaline. For example, magnesium hydroxide is insoluble in water. It's not an alkaline, but it's a base because it will react with an acid to give you salt and water. Then we talked about that the same way you have strong and weak acid, that's the same way you have weak and strong alkaline. Example of strong alkaline is potassium hydroxide and sodium hydroxide. One example of weak alkaline is ammonium hydroxide or aqueous ammonia rather. So these are examples of that's an example of weak alkaline. They will talk about the physical properties that they are slippery to touch. They have bitter taste. That is, bases and alkaline have bitter taste. They are slippery to touch. They turn red litmus blue. And then the concentrated form of these two caustic soda, which is sodium hydroxide and potassium hydroxide, are corrosive. Then we talk about the chemical properties, neutralization reaction. They react with acids to give you salt and water, and then we said they react with ammonium salt to give off ammonium gas. Then we talked about the uses of alkaline and bases. I hope you learned something at the end of the class. So see you in the next class. Keep staying safe, keep reading your books, and God bless you. I remain your chemistry teacher, Sadana Odu.